Assalamu alaikum, my dear students. How are you? Hope all of you are well by the grace of Almighty Allah. Welcome to NIEBS Home School. This is Shahjadi Akter, Assistant Teacher of Science of National English Version School, District. Today I am going to take a physics class for class 10 students. My dear students, our today's topic is Chapter 11, discussion part 2. Our today's lecture number 10. My dear students, this is Chapter 11. This is Chapter 11. Current electricity. This is chapter 11, current electricity. In our previous class we have already discussed about Ohm's law, and in this class now we'll want to start from resistance. What is resistance? Resistance is the obstacle to the flow of current. My dear students, underline this definition. What is resistance? Resistance is the obstacle to the flow of current, and so the more the length of a material L, that is the length L, the higher the hindrance and resistance. So we can say R proportional L. Here R is resistance and L is length. So my dear students, from the laws of resistance we can say the more the length of the material L and the higher the hindrance and resistance. So R proportional L. If the resistance will increase, then the length will also increase. Again, current can flow more easily through a wide path and then through a narrow path. So the higher the cross sectional area A of a conductor, the lower is the resistance. So my dear students, from this equation, from this formula, we can write R proportional 1 divided by A. R proportional 1 divided by A. That means if R, that is resistance, increase, then the cross sectional area will decrease, and if cross sectional area increase, the resistance will increase. So from this, from here we can say the higher cross sectional area of conductor, the lower the resistance. And if we want to write these two things as an equation, that means if we write R proportional L and R proportional 1 by A, if we write these two equation as write these two things as an equation, then rather than the proportional form, a constant rho has to be used. So the resistance R will be R equals to rho L divided by A. Okay, so here R is resistance, L is length, A is cross sectional area, and rho is the conductivity. Okay, so here rho is a constant. Here rho is a constant. So from here we can write rho equals to R A divided by L. My dear students, here rho is constant. Okay, now, and my dear students, you have to learn this formula. Okay, for a certain material, rho is specific resistance and its unit is ohm meter. My dear students, the unit of rho, that is unit of rho, is ohm meter. To measure how conducting a substance is, a term called conductivity, that is sigma, has been introduced. And the more a substance is electrically conducting, the more is the value of the electrical conductivity. So it is reciprocal to the specific resistance sigma. So sigma equals to 1 divided by rho. My dear students, you have to also learn this formula. Sigma equals to 1 divided by rho. Okay, so the unit of conductivity sigma is per ohm meter. Per ohm meter. The unit of conductivity unit of rho is ohm meter, and the unit of conductivity sigma equals to 1 divided by rho, that means per ohm meter. So my dear students, you have to learn this one, and for you have to learn the specific resistance of, here given the table of specific resistance of meter, and that you have to learn properly. The specific resistance of silver is 1.59 into 10 to the power minus 8 ohm meter. The specific resistance of copper is 1.68 into 10 to the power minus 8 ohm meter. The specific resistance of gold is 2.44 into 10 to the power minus 8 ohm meter. The specific resistance of graphite 2.50 into 10 to the power minus 6 ohm meter, and the specific resistance of diamond is 1 into 10 to the power 12 ohm meter, and specific resistance of air is 1.30 into 10 to the power 16 ohm meter. My dear students, we have to remember one thing: the resistance of a substance is the hindrance to electron flow. The more the atoms and molecules vibrate, the more the barrier of the electrons will face while going through them. In other words, the more the resistance as the vibration of the atom and molecule increases with the increase in temperature, so the specific resistance of a conducting substance also increases with temperature. So the temperature has to be specially mentioned while expressing resistance of or specific resistance of a substance. My dear students, now we'll discuss about the fixed resistance and variable resistance. Okay, resistors are of two kinds: fixed resistance and variable resistance. Resistor with a definite value are used in different circuits, and they can be different shapes and different types. The resistances that are used in laboratory uses, generally the value of resistances are expressed by using bands of different colors on them, and how much electric power they can tolerate is also specified along the value of resistance. See here given the picture of some fixed resistance. Here they have 2 points. Okay, they have 2 points, and this is the figure of variable resistor, and we can change this resistance as our wish. Okay, now variable resistance. Sometimes an electric circuit needs a resistance, the value of which can be changed as per need. So this type of resistance whose value can be changed within a certain limit, this is called variable resistance. My dear students, this is the figure of a variable resistance, and the fixed resistance has 2 ends. See, fixed resistance has 2 ends, and variable resistance here has an additional terminal in the middle. Here this is the middle terminal, this is the additional terminal where we can change the resistance. Now come to here is a mathematical problem. The specific here given the specific resistances rho of silver, copper, tungsten and nichrome wire is 1.6 into 10 to the minus 8. The specific resistance of copper, that is rho, is 1.7 into 10 to the minus 8. The specific resistance of tungsten 5.5 into 10 to the minus 8, and the specific resistance of nichrome 100 into 10 to the minus 8 ohm meter respectively. Using this make 1 ohm resistance. Okay, so here given the resistance, the value of resistance R equals to 1 ohm. Okay, so my dear students, we know rho, the formula, that is R equals to rho L divided by A. By using this formula, we can find out the length of that of these materials. Okay, so the length of these materials here given, if we consider area is 1 meter square. Okay, here given the area of is 1 meter square, and the specific resistance of these materials. Okay, so for silver specific specific resistance rho for silver, so you can write S. So rho S here given 1.6 into 10 to the power minus 8 ohm meter, and now we can find out the length. So we know this formula, R equals to rho L divided by A. So from here we can write L equals to RA divided by rho, RA divided by rho. So we can put the value here. R here given 1 resistance, here given R equal to 1 resistance. Okay, so R equals to 1 into A also 1 meter square, and R given 1.6 into 10 to the power minus 8. So it will be 6.25 into 10 to the power 7 meter. So my dear students, this is the length of for silver. This is the length of silver here. So like this we can find out easily the copper, the length of copper, tungsten and nichrome by using this formula. And if we can see that here if we fix the radius that is R equals to 0.1 millimeter, then we have to convert this millimeter into meter. So the radius of if the radius of this material is 0.1 millimeter, then the length will be for silver 1.96, then 1.84, 57 centimeter and 3 centimeter. So my dear students, from here we can see if the temperature of conductor is raised, if the temperature of a conductor is raised, its resistance also increases, and but in case of the opposite for semiconductor. So the resistance, from this formula we can see this also, if the temperature increase, the resistance will increase, and this is opposite for the semiconductor. The resistance decreases if the temperature goes up in a semiconductor. So the reason is there is a free electron in conductor for the flow of current, but a semiconductor does not have free electrons. So if the temperature is raised, some electrons are found for the flow of current. So a temperature rises causes the rise causes the decrease of resistance of semiconductor. So from my dear students, from here one question will come. Okay, so learn properly this part. Now circuit, come to circuit. Every substances has some resistance, but we do not consider the resistance of electrical wires while using them in circuits in our daily life. When a resistance is needed, we use different resistances prepared in special ways. Sometimes we use such resistance for some special purposes, and even where even their magnitude can be changed, and these are called variable resistance or rheostat. We have seen here the variable resistance or rheostat. My dear students, now we will see the symbols, some symbols that are used in a circuit. Okay, see this is the symbol of cell. My dear students, this is the symbol of cell. See, this is the symbol of cell. This is called cell. This is the symbol of battery. Okay, one or two cell makes battery. Okay, this is the symbol of battery. Then see, this is AC source. This is the symbol of AC source. This is the symbol of crossed wire. This is connecting wire. This is wire not connected. This one is one way switch. This one is two way switch. This one is fuse. This is the symbol of fuse. This is the symbol of bulb. Okay, this is the symbol of capacitor. This is the symbol of coil. This is the symbol of variable resistor or rheostat. This is fixed resistor. Resistor. This is galvanometer. This is the symbol of ammeter. This is the symbol of voltmeter, and this is the symbol of earth connector. My dear students, now come to next topic. The amount of current that comes from the higher potential of a source, that is battery, cell, generator, whatever may be, after flowing through the electric circuit, just the same amount of current comes back to the lower potential. Number B, the amount of current that enters into any point of circuit, that the same amount of current will come out from that point, and that is there is no creation or destruction of current in a circuit. Number C, in a circuit, Ohm's law is true for the 2 points of any part, that is if the potential differences of those points is divided by the resistance of part, and the current flowing through the circuit can be determined. My dear students, here are given two circuits. Okay, two circuits with battery cell and a resistor. See, in first circuit, this is the cell, and this is resistor. In second circuit, this is cell, this is resistor, and resistor, these are the cell, the one point of the cell and the another point of resistor is connected, and the another part is connected with earth surface. Okay. And my dear students, now see, now we are ready to analyze a circuit. We may think that we have to understand the circuit completely if we can find out the potential difference in any parts of the circuit and how much current is flowing through the part. There may be many components in a circuit, but like battery cell, resistance, capacitor, diode, transistor, etc. But now we will analyze the circuit composed of only battery, cell and resistance. See, only battery, cell and resistance. Okay, so in a circuit, resistance are connected with copper wire. Through we have seen that the copper wire has a specific resistance, but in reality the resistance of the connecting wire is very small with respect of the resistance we use in a circuit, so we do not consider it at all. We will assume that the wire has no resistance and the potential is the same over the whole wire. So now let us analyze the circuit as shown in this figure. Here resistance is connected to the two terminals of battery cell with two wires. See, two wires. Okay, this since the part CD is connected to the earth, and we can say the potential of the lower terminal of battery cell is 0. Okay, so the upper terminal of the battery has potential V. Okay, and have potential V, and there is a resistance in part BC. There is a resistance in part BC. Potential difference between two ends of the resistance is V equals to V. The potential difference between these two resistance is V minus 0 equals to V. And so if the current I flow here, so we can write from Ohm's law I equals to V divided by R. So current I comes out from point A of the battery and enter up into point B. So we have determined the voltage and current in every point of the circuit. Now let us assume in the same circuit, if we connect AB part with the earth rather than part DC, then what will happen then? As the voltage, this battery cell is volt B and V, so the potential difference between A and D must be B. Okay, A and D must be V, and as the voltage A is 0, so the voltage D must be minus B. So therefore the potential difference between B and C will be 0 minus V, that means V. So the resistances are, so electric current I equals to V by R. So my dear students, now come to next page. This is example of determine the voltage in points A, B, C and D of the circuit in this figure. Okay, we have to find out the voltage at point A, B, C and D in this figure. So the voltage C and D is 0. See, my dear students, see the voltage C and D will be 0 because this terminal is connected into with earth. Okay, that's why their voltage will be 0, and voltage A is 3 volt here given. See, the voltage here given 3 volt. To calculate the voltage B, we have to find out the current. Okay, so I will be V divided by R. Here V is 3. Here V is 3 volt, so V divided by R means here 2 resistance. See, R, 2 R, 1 ohm and this one is 2 ohm. So it will be 1 plus 2, that is 1 ampere. Current is 1 ampere. So the reduction of voltage from A to V is V equals to IR, that is R here given 1 ohm into I means 1. So it will be, voltage will be also 1 volt. So the voltage at point V is 3 volt minus 1 volt, that is 2 volt. So as the voltage, all the points has been found and verify whether Ohm's law works or not. My dear students, I hope all of you have understood our today's topic. See you again in the next class.